Resistivity and conductivity na one topic wey be say many students no dey understand for physics, especially when dey dey inside exam. Make I no lie, I get problem for resistivity and conductivity when I dey secondary school, but then for this video I go help you make you understand am well, and that one go help you solve this kind of question when you see am for exam. So if you say na lie, resistivity dey easy, I want to make you pause this video and try this question. The question say, what length of resistance wire of diameter 0.3 millimeter and resistivity 1.1 times 10 to the power of minus 6 ohms meter you will cut from a roll of wire to make a 14 ohms resistor? This na the kind of question wey dem give for WAEC or for JAMB exam or for GCE exam. Many persons wey take this kind of exam fail am. For this video, I go teach you how you go take solve this question, and you go see say you go find am very easy. Now, to solve this question, we will talk some little thing about resistance before we go solve this question. Resistance, resistivity and conductivity. Now, when we talk about the resistance of any material wey dey in form of wire, that resistance of any material wey dey in form of wire dey equal to, or e dey directly proportional to the length of that wire, and e dey always dey inversely proportional to the cross-sectional area of that wire. That means say if I get a wire like this and I wan find the resistance of that wire, that means say the length of this wire matter and the cross-sectional area of this wire also matter. Cross-sectional area na this side, the diameter and also the length, e also matter. So that means the resistance of any wire dey directly proportional to the length and inversely proportional to the area of that wire. That means say as the length of this wire dey increase, the resistance dey also do wetin? Dey also increase. Na im make for electric wiring, if you go out dey waka for street, you see long wire, you always break am with poles, because if this wire long too much, the resistance go increase. But when they break am into small circuits, the resistance go reduce. And you know say resistance na something wey no dey good for electricity flow of current, because e dey stop current from moving. So if you dey short, e better, because the resistance go do wetin? If e dey longer, the resistance go wetin? Go also increase. So if e dey shorter, the resistance go also do wetin? Reduce. But then the other one wey we go look at na the cross-sectional area. That means say if the wire or conductor dey very big, wetin go happen to the resistance? The resistance go do wetin? Go reduce. Na im make in most of this advanced country, people dey always use big cable to transfer direct current to far places, because when you use big cable, you go get lower wetin? Resistance. So you see, resistance dey directly proportional to the length, and e dey inversely proportional to the cross-sectional area, because if the cross-sectional area increase, resistance go reduce, and if the cross-sectional area reduce, resistance go do wetin? Go increase. So that one tell us say this sign of proportionality sign, we fit replace am with wetin we dey call the resistivity of any conductor. So that means say the resistance dey equal to the resistivity times the length divided by the cross-sectional area. And this na the formula of resistivity, na the formula of resistance. Now, if we wan calculate the resistivity wey be this rho P, e go dey equal to the resistance times the cross-sectional area divided by the length. And that one go mean say resistance na wetin? Na ohms, times the area na meter square, times the length na meter. So when meter cut 1 meter, that means say the SI unit, or standard international unit, for resistivity go dey equal to what? Ohms wetin? ohms meter. So how we could take define resistivity of any conductor? The resistivity of any conductor they happen when the cross-sectional area now 1 and the length they equal to 1. Now, when we put the cross-sectional area to be 1 and we put the length to be 1, wetin go happen? Resistivity go dey equal to wetin? To resistance. So the resistivity of any conductor na equal to the resistance of that conductor when the length of that conductor na 1 and the cross-sectional area of that conductor na wetin? Na 1. Now make you take note of one thing, and this one dey very important, make you take note of am. Say the cross-sectional area of any conductor, it is very important for you to know. Say the cross-sectional area of any conductor they equal to pi times the distance square divided by what? By 4. And that's now the cross-sectional area of any conductor. Now this one means say we could fit find the resistance of any conductor. And wetin be the resistance? If the resistance give us rho length divided by A. Rho of length divided by A. Wetin we will do? We go fit find the cross-sectional area. Now if we put the cross-sectional area to be wetin? To be pi d square divided by 4. We will get our resistance to be equal to rho divided by pi d square divided by 4. So this one will automatically give us 4 times rho times length divided by pi d square. So that means the resistance of any wire could fit be equal to 4 times the resistivity times the length divided by pi d square. This is another formula wey we calculate the resistance of a conductor, especially when they give us the diameter of that conductor. So for this kind of question, now the kind of question we can give us the diameter of the wire, and this formula we go use. Now after we don't explain all these things, we will use the formula we will take solve that question. Now to solve this question, we will look how we will take apply this formula, use and solve that question. To apply this formula, use and solve that question, the first thing what they tell my students say, if they give you any question like this, first of all ask yourself, now wetin they give me for this question? Wetin they say make I look for, and now which formula I could use? Now for this question, they give us the diameter and say the diameter they equal to 0.3 millimeter. And you know say the unit for length live in millimeter. Now wetin? The unit of length na meter. So we need to convert that millimeter to wetin? To meter. Now remember say 1000 millimeter na it make 1 meter. So if 1000 millimeter make 1 meter, then 0.3 millimeter could give us wetin? It will give us 1 meter times 0.3 millimeter divided by 1000 millimeter. So millimeter could cut millimeter, and that one will remain wetin? 0.3 divided by 1000 meter. So that means this one, the diameter could give us 0.3 times 10 to the power of minus 3 meter. Because this 10 to the power of minus 3, 9, it just be like when you get 1 divided by 1000. So we don't get that one. And if we want to simplify this one, our D could be equal to 3.0 times 10 to the power of minus 4 meter. Because at one decimal place, we can't go one here. It will give us minus times 10 to the power of minus 1. If you add them to this one, it will give you minus 4. So D, 9 be this. So wetin they give us again? they no give us the length, they give us resistance. Wetin they say be the resistance? Resistance R, they say it dey equal to 14 ohms. Wetin dem give us again? They give us the length, they no give us the length. They say make we find the length. Na im dem say make we look for. Wetin they give us the resistivity? The resistivity, they say na 1.1 times 10 to the power of minus 6 ohms meter. We don get everything wey we dey look for. So wetin we need to do now na to apply the formula. If we apply the formula, we'll get our resistance to be equal to 4 rho length divided by pi d square. So our length now will give us wetin? L go dey equal to, this go calculate, multiply this, that one will give us r pi d square divided by rho times length. So make we put all our parameter here. We will get our length to be equal to, the resistance now 14 times pi could be 22 divided by 7 times the diameter now 3.0 times 10 to the power of minus 4. Remember, this one are ohms and this one are meter. Then this one are 7. So wetin we will get this one? Rho now wetin? Times 1.1 times 10 to the power of minus 6. Remember, this one now ohms wetin? Ohms meter. Remember na wetin? Diameter na meter square. This could be square. So that means our m here could be meter square because d na square. So we will get our length to be equal to 14 times 22 times 3 square could give us wetin? 9 times this one will give us 10 to the power of minus 8 because minus 4 times 2 will give us minus 8 divided by 7 times 1.1 times 10 to the power of minus 6 ohms meter. Why this one will give us meter square? This one will give us ohms. So wetin we go do now be say 7 here will cancel here to give us 1, and then 7 here will give us 2. Wetin remain na 22. So we fit still cancel something. If we cancel something, we will see say 2 times 22 will give us 2 times 22 will give us wetin? If we cancel, so from here if we make 4, so we go use the formula R equal to 4PL divided by pi d square. So if we make L the subject of formula, we will get our L to be equal to R pi d square divided by 4p or rho. So wetin we will do now to find wetin L be. So our L could be equal to, the resistance now 14 times pi now 22 divided by 7 times the diameter, we get them as 3.0 times 10 to the power of minus 6. All of them could be square, and all of these could be divided by 4 times 7 times 1.1 times 10 to the power of minus 6. Remember, this one na minus 4. So if we get this one as minus 4, wetin we need to do now to simplify. So if we simplify, 7 here will go here to give us 1. 7 here will give us 2. So wetin we will do now to also cut here. 2 here will give us 2, and 2 here will give us 11. So wetin we need to do, we don't reduce our, wetin remain, 2 here will give us 1, 2 here will still give us 1. So wetin we get remain now 11 times, our length will be equal to 11 times 3 square could give us 9 times 4 to the power of 2. 4 times 2 will give us 10 to the power of minus 8, and all of this one will be divided by 1.1 times 10 to the power of minus 6. So you see, we don't reduce small. So 11 times 9, our length could be equal to 99 times 10 to the power of minus 8 divided by 1.1 could give us wetin. If we take this one down, this one will give us 11 times 10 to the power of minus 7. So if this one simplify, that whole expression will come give us this. If we simplify that one well, that whole expression will give us our length to be equal to 99 divided by 11 times 10 to the power of minus 8 multiply or divided by 10 to the power of minus 7. 99 divided by 11, our length will be equal to 99 divided by 11 will give us 9 times this one na division. It means we will get 10 to the power of minus 8 minus bracket minus 7, because according to the law of indices, these two go minus. So we will get our length to be equal to 9 times 10 to the power of minus 8 plus 7. Minus 8 plus 7 could give us our answer to become 9 times 10 to the power of minus 1. And if we get that one, that means our length now will be equal to 9 times 10 to the power of minus 1. If we move 1 0 here, it will give us our length to be equal to 0.9. So if na 0.9, remember, say na in wetin in meter, because here meter square dey here na ohms, here na ohms meter. So when I cut 1 meter, it could remain meter. So in centimeter, the length of the wire we go need na 90 centimeter, and that one na the length of the wire we go need in order to do wetin, in order to make a 14 ohms resistor. So you see, say they very easy as long as you know the formula. Say resistance they equal to 4 times PL divided by pi d square. Make you get that formula for your head, so that anytime we can tell you resistivity and they can't tell you the diameter of a conductor, you go fit apply this formula and you go solve them easily. This na the points we want take. Now when we talk about conductivity dey very easy compared to resistivity. Conductivity na just the opposite of resistivity, because conductivity na just the ability of any cable to conduct electricity. So that means the conductivity which we would represent by this, they equal to 1 divided by the resistivity of any cable. So that means say our rho fit dey equal to 1 divided by, you remember say resistivity na the resistance times the area divided by the length. So that means our conductivity could be equal to the length divided by our resistance times the A. And that one could be the formula for conductivity. So anytime we then tie conductivity to resistivity, make you play around with the formula. If you play around with the formula, you will be able to get your answer very easy. And when you learn how to play around with all this formula, any question where they ask you for conductivity and resistivity, you will be able to answer the question because you don't carry all the formula for your head. This na unique Pidgin Academy, where we dey help people understand physics for our mother language. If you like this video, make you no forget to give am a thumbs up, make you share am with friends and colleagues, and remember to subscribe to my channel for more of our unique physics tutorial. Thanks so much for watching.